Last week, Arc blockchain went live on public testnet. Arc is the new EVM L1 built by Circle, the inventor of USDC, one of the largest stablecoin in the market. It is now open to developers, which means builders can deploy smart contracts, test core features, and access all the key resources. In this short video, I will tell you everything you need to know and get started as a builder on Arc blockchain. So let's get started. First thing first, Arc is EVM compatible. That means you can deploy and interact with the smart contracts using the same tools and languages and frameworks such as Solidity, Foundry, and Hardhat, right? But there are few key differences to that. First of all, which is the major one, is USDC, the stablecoin, is used as native gas, which means all fees and balances are denominated in USDC and not ETH. But there is one more interesting thing that I want to discuss. So on Arc, there are two versions of that USDC. One is the native USDC and the other one is ERC20 USDC. So USDC isn't just a token on Arc blockchain. It's the base currency of the entire chain. So just like ETH on Ethereum, every account on Arc holds USDC natively at the protocol level, right? And that's what you pay. That's what you use to pay for the gas. And Arc replaces ETH with USDC as the unit of the account in the EVM state trie. So, but Circle wanted developers to still use the familiar ERC20 functions like transfer from or approve, etc. Right? So they exposed an ERC20 contract interface at a fixed address on the testnet, which is shown just here in the docs. So you can go and check out this address, and this is right now on testnet. Okay. So they exposed it at a fixed address. For the mainnet, this address might change, so you might want to look at it later. So that contract doesn't, store a separate balance, right? So this particular contract, it simply reads and updates the same underlying native USDC ledger. So when you check your balance via like ETH get balance, method, you will see it with 18 decimals, right? And then if you use it like with simple ERC20 contract, like balance off method, right, then you will see it with 6 decimals. So these two versions have, different decimals, right? This one is to match with like normal USDC. So if you go to different chains on, Ethereum or any other L2 or Solana, the ERC20 USDC has 6 decimals, right? So which is pretty interesting because native one has 18 and this one is 6. So you have to make sure that you're using correct decimals when, doing the calculations, right? So, and under the hood, both point to the same account balance. So if you spend from one, the other drops two, right? And you're not holding two tokens. For example, on Ethereum, if you're using if you're holding a wrapped ETH, then it is a different new token and it is visible on your portfolio that you have ETH and then you also have wrapped ETH. But in here, you're not holding two tokens. There is no separate map, right? And you're holding onto one USDC balance that can be viewed and used in two different formats, right? So super cool for UX and tooling compatibility, but definitely confusing at first glance for developers. But if you're writing contracts or integrations, never assume both use the same decimal precision and normalize amounts before mixing RPC and ERC20 calls. So moving on, the next feature is deterministic finality. So Arc blockchain gives you deterministic sub-second finality for every transaction. So once a block is committed, any transaction in that block is instantly and irreversibly final, right? So with Arc blockchain, the transaction is like either confirmed or unconfirmed, like it is final or unconfirmed. There is like no probable final state. As in other blockchain, you wait for this amount of time, this particular seconds, in which you're waiting for that particular transaction to get confirmed or get rejected or whatever it is, right? And one of the benefits, like as a developer, is that you don't really need to build a retry or like a rollback logic for reorg if reorg ever happens to that particular blockchain, right? And this is possible via the architecture. I mean, as a application developer, it's not really necessary to go through that, but Arc uses the same two core components, just like Ethereum, consensus layer in the execution layer. There are two layers, and then it runs on Malachite, which is a high performance implementation, BFT. And as I said, the transaction cannot be like reorganized and rolled back once it is committed, and block finalizes in less than 1 second. So you can check out this architecture in their docs if you want to read more about it. And then, and it is built on like familiar EVM compatible stack, like Reth, right? Reth is like this client written in Rust, which is like pretty much fast. And, it has like new methods. Like, for example, there is a new method, ETH raw send transaction, which is a new method for like reading the blockchain faster. So all these methods, are available as well on the Arc blockchain. The next thing is simplified block time. So blocks are timestamped by real time and not epochs or slots. And there is stable gas fee model. But what does this mean? So basically, Arc fee market is built on Ethereum's EIP 1559. If you don't know what is that, Google that. But that changes how the base fee is adjusted. And instead of like recalculating the fees every block, the Arc uses an exponentially weighted moving average of the block utilization. So this has like few key advantages, benefits as a developer, which you can use, which means that you don't like need to have like a complex fee estimation logics, and it's typically like around 1 cent per transactions in like dollars. And also you don't really need to hold a volatile token like ETH or BTC or whatever it is, right? And stable fees, despite network congestion, how much traffic is on the chain, there will be like stable fees, and it definitely reduces the integration fixture for like enterprise and also the new fintech customers that are coming on chain and building on chain. And it is that there is flexibility to like sponsor fees or accept multiple stable coin without custom workarounds like using external account abstraction solutions. And not just this, Arc is planning to add more features like accept fees and stablecoin beyond USDC, so including EURC, USDT, and other stablecoins, and then also sponsor user transaction by paying fees on their behalf. So you can do that too as a developer, and programmatically define custom fee rules such as like discounts or subsidies, which I think is a really awesome feature. So that is it. This is pretty much about Arc blockchain, the new Circle EVM L1. If you're building on the Arc blockchain, you can definitely check out this EVM differences section. So shout out to them for having this section, and you can compare it with the Prague EVM fork and what are the differences between the Arc EVM. There are a few things that are also mentioned here. So if you're building, you can check it out. The denomination, which we already discussed a bit, and then about timestamp and randomness. Obviously, don't use the blockchain randomness. Always use like an external oracle like Chainlink or PIT for generating randomness. But avoid assuming strictly increasing like values for on-chain time comparison. So, do read out all their documentation and check it out. There's also a tool section, like what are the tools that are supported on the Arc blockchain. That being said, Alchemy has full support for Circle's Arc blockchain. So, you can go to Alchemy and get your API key and, start building today. And as I always say, like, builders always win in crypto, and you will always be rewarded for building. So get your key and start deploying the smart contract, and start building good things. And if you need any help, feel free to DM me or join our Discord server. Happy to help you. Thank you.